Hello again. This is the final video tutorial, number 3.2, under the system of video tutorials developed under the Flood-CBA 2 project by the Flood Hazard Research Centre at Middlesex University. Like video tutorial number 3.1, this is concerned with safety and the flood risk reduction that we obtain with different levels of intervention at different standards of protection. Again, we're looking at costs and benefits, and again, we're recognizing that the benefit side of this equation is where there is greatest uncertainty, so we have to be careful how to proceed. This particular video tutorial concerns 3 case studies, the first in Lavara, Greece, the second in Amadora, Portugal, and the third in Écija in Spain. Each one of those has been undertaken under the Flood-CBA project. In terms of Lavara, we see here the city of Lavara surrounded by floodwater, but also a roadway in the near side of the diagram, in the foreground, as it were, which is the new road being constructed as a bypass to the city, or the town rather. There is flooding and flood damage in the town in this photograph, and there is the new national roadway, which is about to bypass that particular town. So here is a map of the site with the town of Lavara shown yellow, and the first intervention that is being proposed is to close up the underpasses in that roadway and thereby stop the flood water coming from the floodplain into the town. Those underpasses were provided so that farmers could actually get to the fields in the floodplain, which you can see here. The second intervention is right in the middle of the floodplain and involves some sort of bypass channel shown here in red. That was an intermediate solution because the third solution being proposed was a much more substantial levee or embankment right along the Greek side of that main river. So that's the short list that we're analysing in the Lavara case. And to cut a long story short, we see in the task 22 that the benefit cost ratios are very healthy for closing the road and rail gaps. That's option number 1. A benefit cost ratio of over 190, indicating very worthwhile extra expenditure over and above the current situation with regard to the design of that particular road. The other interventions show good benefit cost ratios of 44 and 22, showing that they too could be, if stood alone, an efficient way of investing money to reduce risk in this particular location. However, when we look at the incremental benefit cost ratio, as we did in the previous tutorial for Oxford, we see that the incremental benefit cost ratio of option 2 and option 3 now are well below 1.0. indicating that the costs of moving from the very simple closing road and rail gaps, the costs are far in excess of the benefits of going towards the interventions involving the bypass channels or the main embankment along the main river. So we see the first option as being the best, the most efficient use of money and commensurate with providing a good degree of safety for the town of Lavara. The other options are not nearly so favourable. The benefits do not exceed the costs. So the questions we're asking here, as in other case studies, what is the best option? And the best option here appears to be option 1. In Amadora, Portugal, the situation is completely different. Here is an inner city situation where flash floods create the kind of situation we see in the photograph here, a lot of damage and a lot of disruption. The floodplain is quite narrow, and the area analysed under the Flood-CBA project has a range of return periods as indicated on this map. The shortlist, again, that we have to consider under the Flood-CBA system in Pro Forma D is again do nothing, quite correctly. Secondly, cleaning the urban infrastructure and riverbanks so the flow of floodwaters is more efficient. Thirdly, building or rehabilitation of the structural intervention, which is partly decrepit. Or fourthly, rehabilitating the river channel into a more natural form. That's the short list of interventions being proposed for Amadora. And here is again the kind of spreadsheet we saw for the Oxford scheme in tutorial 3.1. There we have the present value of costs of something like €667,000 against the benefits of over 5 million. So again, what looks like a very healthy benefit cost ratio of indeed 4.95 for option 4, and even higher benefit cost ratio of 15.4 for the more modest option 2, which obviously is at lower cost but delivers fewer benefits and less safety. In terms of the incremental benefit cost ratio, we see favourable figures here. An incremental benefit cost ratio of going from option 2 to option 3 of 13.3, which is very good indeed. And an incremental benefit cost ratio of going from option 3 to option 4 of 4.27. So again, we see favourable incremental benefit cost ratios, in this case favouring, I think, probably option 4 if it can be afforded. So the best option is probably option 4 in this case, whereas if you remember, the option number 1 in the Lavara case was the one that the economic analysis favoured. Now the third case study is the town of Écija in southern Spain, and what we have here is a map of the floodplain and a map of the city, a hydrograph showing the rise and fall of the floodwaters during particular flood events, and a little photograph at the top of the flood and people defending properties with floodboards in front of their front doors. Again, we have the basic do-nothing situation to compare against the do-something situation. And in this case, we have some quite ambitious intervention possibilities, improving of dikes and embankments, creating a safety floodplain, and case for a dam further upstream in order to restrict the flow of floodwaters into the town. This kind of map here shows the cadastral measurements of property types that was undertaken by Rediam for the Écija case study, a detailed analysis property by property of the likely effect of flooding on those particular communities. A map here with the cadastras, but also the photograph showing the town from the opposite bank. Here we have a map of the floodplain as modelled by Rediam, showing the extent of the 50 and the 100 and the larger flood events up to the 500-year event. In terms of benefit cost analysis, which is after all what Flood-CBA 2 is all about, option 1 has a very favourable benefit cost ratio of 14.4 and a cost of €150,000. As we go up towards the more ambitious interventions, we see increasing costs as we do normally, and the situation where the incremental benefit cost ratio is actually quite favourable towards moving from case 1 to case 2. Case 1 to case 2 shows an incremental benefit cost ratio of over 4, so that's a very healthy result. The incremental benefit cost ratio for case number 7 is less than 1, showing that that is not a favourable result, going for the dam plus other intervention options. So the choice that Rediam is making or suggesting for Écija is case number 2, some careful use of the floodplain, new dikes and embankments, considering that incremental benefit cost ratio. So, again, we conclude that an intermediate level of standard of protection, if you like, is favourable here in comparison with the low standard in Lavara because of its efficiency and the relatively higher standard at Amadora. This is the kind of choices that we're faced. This is the kind of analysis that Flood-CBA is leading to. So to summarise the 4 case studies, in Oxford the bypass channel was just about worthwhile but very expensive. In Lavara the inexpensive minor intervention, stopping up those arches under the road, was a very easy early winner in terms of economic efficiency. In Amadora the basic infrastructure cleansing is very efficient, but reclaiming the watercourse is worthwhile, although rather much more expensive. In Écija in Spain, A middle design standard intervention is chosen, not the upper catchment dam, which would have been more than 5 times the cost. So the best option is decided with a balance of economics and, of course, many other considerations. So, just to conclude, the Flood-CBA2 system uses cost-benefit analysis, as we discussed in tutorial 3.1, to maximize outputs compared to inputs, maximizing the efficiency of investment to reduce flood risk, getting the best value for money. That's the objective. But it means that we have choices, and these are revealed by the analysis, I think, in these tutorials. We have choices between balancing costs, benefits, and safety. We can maximize safety, but it's expensive. We can minimize costs, but we lose safety. So the whole comparison is between the benefits, the costs, and the safety that we're able to provide using taxpayers' money to protect our communities from flood risk. Thank you very much.